Hi, welcome to the video solution for physics. This is Edexcel IAL Physics Unit 2, January 2018, Part 2. Let's start. Question number 12. A teacher carried out a demonstration using microwaves with a wavelength of 3 centimeter. The microwaves were directed towards a gap of about 3 centimeter between the two aluminum plates as shown. Microwaves were detected at point X. So this is point X, aluminum. Explain why microwaves were detected at point X. Actually, what is happening, you know that if some waves, uh, if passes through the gap, after passing through the gap, the waves diffract. Diffract means they spread out. So you can imagine when the first wavefront comes out the gap, it comes out like a circular wavefront, and this behavior of the wave is called diffraction, and this is called spreading out. So due to spreading out of the wave can reach at point X. So you can say that because the gap size, this is the gap size, is equal to the wavelength, that means you have a maximum diffraction, and wave gets diffract and spreads out and reaches at point X. That's why we can observe the wave at X. Part B, an extra aluminum plate was added, so the microwaves were now incident on two gaps as shown. These are two gaps, waves are coming. A microwave detector was moved along the line AB. Variations in intensity were detected. Explain why several points of maximum intensity and a minimum intensity were detected. Okay, so it's all about maximum intensity is there and minimum intensity. If you see, this is all about interference of the wave. This maximum is due to constructive interference, and this minimum is due to destructive interference. And again, same keywords that you can use here, that if something happen to the wave due to which the waves interact and they produce either constructive interference or destructive interference. And even if you say that if the path difference is n lambda and waves are in phase, so you can say that you can have a constructive interference, or in this case you must write that you will observe maximum intensity. And if path difference is n plus half of lambda, that means the waves are anti-phase or out of phase. That means they will interfere destructively, or you will observe minimum intensity. So you can start your answer like, after passing through the gap, the waves diffracts from the two slits, and after diffraction the two waves interfere, and these are the conditions for interferences. '13. The photoelectric effect occurs when electromagnetic radiation of a suitable frequency is incident on a metal plate. Observation of the photoelectric effect provide evidence in support of particle model of light. A zinc plate is illuminated with radiation of varying frequency f. The graph shows how the maximum kinetic energy E max of the emitted electron varies with f. The frequency at which the line crosses the x-axis is known as the threshold frequency. State what is meant by threshold frequency. So threshold frequency is the minimum frequency of incident photon at which electron just emitted from the metal surface, and generally from graph the x-intercept represent threshold frequency. So for this specific case, threshold frequency is 1 into 10 to the power 15. But you don't need to write this number. They are asking about just the definition or the concept of threshold frequency. So threshold frequency is the minimum frequency required to emit electrons from the metal surface. Explain how the existence of threshold frequency supports the particle theory of light and not the wave theory of the light. So in this case, you will have to write Einstein explanation in which, if you recall all the points, that the photoelectric effect is in fact a 1-1 interaction between photon and electron. That means one photon is absorbed by one electron, and after absorbing photon transfers all the energy to the electron gets energy, and then it comes out from the metal, and that means electron needs a specific energy, a certain energy, to overcome the nuclear forces or to come out from the metal. And this certain energy corresponds to the frequency of the incident photon. These are the typical keywords, and remember, whenever the question comes about the particle theory and the relation with the photoelectric effect, so you generally write a similar point. That again, I'm giving you again that the photoelectric effect is a 1-1 interaction. Photon absorbed by the electron has increase in energy, and this energy depends on the incident photon frequency. And what about the wave theory? According to the wave theory, when a wave is absorbed by electron, it transfers energy to the electron, and according to the wave, that electron can be emitted at any frequency. So there is no need for threshold frequency, which is against the observed behavior. That's why wave theory is unable to explain. Okay. Radiation with a frequency of 2.4 10 to the power 15 hertz is incident on the zinc plate. Determine the maximum speed of the emitted electron. So you are given frequency and you need to find the maximum speed. So to find the maximum speed, you know that kinetic energy Ek gained by any electron is equal to the energy of incident photon. And because you need to find the maximum speed, so you must need maximum energy, and this maximum energy we can find from the graph corresponding to this frequency. So if you see 2.4 10 to the power 15 hertz, so this is 2.1 2.2, and this is 2.4, and corresponding energy is this much, and then this is 5.2 electron volt. So Emax, maximum energy corresponding to the given frequency, is 5.2 electron volt, and I'm multiplying with the 1.6 into 10 raised to the power minus 19, so that I can convert this electron volt into joule. So when you multiply these two, you have a 8.32 into 10 to the power minus 19 joule of energy. And then finally you say that half mv square equals this energy, and then v square is equal to twice of 8.32 10 to the power minus 19 divided by mass of the electron, and mass of the electron from your data sheet is 9.11 10 to the power minus 31. This is v square, and after calculating this you can take a square root. So if you remove the square root after calculating, so v would be equal to 1.4 into 10 to the power 6 meter second inverse. A string is fixed at both ends and held under tension. When the string is plucked at its midpoint, a standing wave is formed on the string. The photograph shows the string vibrating at its fundamental frequency. Explain how a standing wave is produced from the traveling waves. So when two coherent waves moving in opposite direction, so one wave is coming rightward and the other one is coming leftward, these are coherent waves traveling in opposite direction. When they interfere or superpose, they give pattern of maximum or minimum, or you say that the pattern of nodes and antinodes, and this pattern of nodes and antinode is called standing waves. So these are nodes and these points are called maximum points are called antinodes. So you just need to write definition: two waves moving in opposite direction interfere, produce pattern of nodes and antinodes. The graph shows how the displacement of midpoint of the string varies with time as the string vibrates at its fundamental frequency. This is displacement and the time axis. And calculate the length of the string. The speed of the wave on the string is 380. So meaning the string vibrates at its fundamental frequency. That means you have fundamental loop or you have first harmonic. And for first harmonic, just for easy understanding, a wave consists of just two nodes and one antinode. This is called fundamental loop. So N, A and N, or you can say that this is also a fundamental loop. Instead of NAN, this is ANA. Both are fundamental loops or both are first harmonic. No matter which formation do we have, the length of the loops or length of the string or pipe L is always equal to lambda by 2. And we need to calculate the length of the string. That means for fundamental loop, length is equal to lambda by 2. So we need wavelength, but we don't have wavelength, we have graph. If you see, this is displacement time graph, and from this graph we can figure out time period of the wave. If we can figure out time period, then using this t we can find frequency. F is equal to 1 upon t. Once we have a frequency, so we are given speed, we can use f lambda is equal to v, and lambda is equal to v by f. So we can figure out wavelength, and we can use this wavelength here to find the length. So let's just find the time period. So as per this graph, this is one cycle. Till here you have a time. So time is 4. So capital T is 4.0. Remember, again, there is a most common mistakes just generally students do. They forgot this. And remember, this is not speed, this is millisecond. Milli means 10 to the power minus 3. So this time period for one wave is not 4, this is 4 into 10 to the power minus 3 second. Now you have a time period in second. You can do F is equal to 1 upon T, and so frequency will be equal to 250 Hertz, and then lambda is equal to V by F. So length, if you substitute lambda V by F here, so length would be equal to V by 2F. So V is 380 divided by 2 times of 250, and then length is equal to 0.76 meter. Question 15. The photograph shows a speed gun used to measure the speed of car. The speed gun emits pulses of infrared radiation every 2.25 seconds. The pulses are reflected by a moving car and then detected by the speed gun, which calculates and displays the speed of the car. Part A. The speed gun was pointed out a moving car. One pulse was detected 533 nanoseconds after being emitted, and the next pulse was detected 571 nanoseconds after being emitted. So if you see, okay, now calculate the speed of the car. Fine, you need to find the speed of the car. They might ask you, they can add one more question, whether that the car is moving away or coming closer. How do we know? If you see the time difference, the first wave is being received after 533 nanosecond, and the second wave is being received 571. So time of receiving wave is increasing. That means car is moving away. And what is the meaning of this question? You can think of a device like a speed gun. I'm using the same speed gun. Suppose this is the first position of the car where the first wave is sent. So this is the first wave. First wave sent and then reflect. So ray number 1. And the time of coming back is 533 nanosecond. Now when the second wave is sent, the car moves a little further from the gun, and the second wave sent and then reflected. So what do? We need to find the this extra distance traveled by the second wave, and we use this distance because this s, or this extra distance traveled by the second wave, is equal to the distance traveled by the car. So we can use this distance for the car and the time to figure out the speed. So first we need to use the information about the radiation to figure out the extra distance, and then we can do rest of the work. So the idea is this extra distance, I'm just giving some symbol SR, distance traveled by the radiation. This SR would be equal to VT divided by 2. Remember, I'm using 2 because this is pulse and echo. In pulse and echo, we always use double the distance. S is going one way and then coming back, so that's why we use 2. And this V is the speed of radiation, infrared speed of light, and T is the time interval difference between these two instances. So V is 3 into 10 to the power 8. T is the time interval for the radiation, so 571 minus 533. Remember, don't forget to put nano, 10 to the power minus 9 divided by 2. If you solve this, SR, the extra distance traveled by the radiation, will be 5.7 meter. So this is the distance traveled, extra distance traveled by the radiation. So the distance traveled by the car during this pulse and echo procedure. And these are two waves are separated or sent in this 0.25 interval. So this is the time interval. So we can figure out the speed of the car. Speed VC, speed of the car, is distance divided by the time, 0.25, and then 22.8 meter second inverse. This is the speed of the car. Okay, explain why there is a maximum displacement at which the speed gun is effective. Yes, of course, there is a possibility that after reflection, the intensity of the reflected waves might decrease, or it won't reflect. The pulse will not reflect. So there are many chances. So there must be some maximum distance for measuring the speed of the car. Thank you very much. Have a nice time.